Hello everyone. In this video, we will explore the step-by-step process of the design of a steel roof. We will start from modeling the steel elements on ProtaStructure, and move on with the steel detailing and connection design with ProtaSteel. First of all, when we model a steel roof over an RC structure, we should check the height of the roof on architectural drawings. Then, after we complete modeling the RC structure, we can start modeling steel roof by inserting a new story on top of the building. For this purpose, we go to Building Setout tab and select Insert Story option from the Story Operations drop-down menu. On this window, we specify the properties of the new story. Since this structure already has 3 stories, we will enter 4 as the story number. Then, we will enter the height of the steel roof into the Inserted Story Height field. Let me remind you that you can also insert intermediate stories and generate members from a selected story to the new one through this window by checking these boxes. Now, we can start modeling the steel elements of our roof. For starters, we will insert the steel columns by using the Modeling tab on the ribbon menu. Before the insertion process, let's open the Section Manager and adjust the section properties of our columns. Here on this window, you can see all the predefined steel column sections in accordance with various international design codes. All the geometric and material properties can be managed through Section Manager. For this structure, we will insert 100 by 100 box profile columns. After making the necessary adjustments on the properties, we can insert the columns by simply clicking at the axis intersections. Since this is a roof, of course the height of the columns on the edge is different than that of the inner ones. Yes, we inserted a column here already, but we can change its height by simply using the Properties window. We will simply select the column, go to the 3D tab, and enter the proper height specified on the architectural drawing. Since the last change is still active, we can keep inserting the columns throughout the edges. We can move on with the trusses now. Steel trusses will be inserted between the columns. In order to insert a truss member, we click on the upper end of the columns. As soon as we define the endpoints for the first truss member, the truss generator window will pop up. Here we will choose the proper type and pattern for our trusses. Let me remind you that, with ProtaStructure, it is possible for you to define a unique truss type for the project by using the user-defined truss generator. Also, you can choose a predefined truss type from the library. Once a truss type is selected, the member is shown on the preview window. Then, as you make the necessary changes on the geometric properties, this window gets updated continuously. These properties can be adjusted after the insertion as well. Let's define some extensions to our trusses now. We open the truss generator again. We can adjust the section types for the extensions separately through the Members tab. We will select the proper section type for our trusses among the predefined section types in accordance with the international design codes. Here, we adjust the section types for each member of our truss separately. You should pay attention now. Here comes a trick. You can select the same section type as you selected for the previous members from the Project tab without making all the selections again. We will make similar adjustments for diagonal and vertical elements as well. Lastly, we can check and make the necessary changes on the supports at the ends of each element. After completing the adjustments on properties, We can start inserting the trusses now. The trusses can be inserted by either selecting the columns to be at the ends of the trusses, or using the copy and paste commands. Since the last section settings are still active, we can directly insert the column and copy this one for the rest of the trusses. We need truss members at the corners as well. Now, we need to insert the steel beams. Well, here we have two options, steel beams and frame members. We will insert frame members as beams for this roof. Frames can be inserted individually, or as a group between two members. We chose to insert frames instead of beams because frame members are flexible elements. They can be used as beams, purlins, or girts easily by making the proper selection on the Properties window. For inserting them as beams, the general option should be selected. We are inserting the frame members by simply clicking at the upper ends of the columns. The adjustments can be done through the Properties window. The alignment of the analytical wire can be easily checked on the model. The reference point of the analytical wire can be adjusted through the 3D tab of the Properties window. We will now assign supports to the ends of the frame members. The degrees of freedom at both ends of the frame member are managed through the Properties window. In order to define a hinge support, all you should do is clicking at this button twice. From now on, the frame members to be inserted will have the exact same properties already defined. Before inserting the girts, let's check if the trusses are adequately inserted to the model. For this purpose, we use the Measure command from the right-click menu and measure the distance between the trusses. As a result of this check, it seems we need to insert additional frame members to provide adequate stability over the shorter edges. For this purpose, we insert columns at the points where the new members will be inserted. We can just double-click on an existing column to generate the new one with the same properties. As a second step, we insert a frame member between these trusses and adjust the section angle using the command on ribbon menu. Now, we can insert the diagonal frame to support the girts and repeat the same procedure for the other side of the roof. We are ready to insert the purlins now. As soon as you select the truss members, the Purlin Manager window opens. Here, we adjust the section properties of the top and bottom profiles and the section alignments on the chords. The generation method and the placement can be checked through the preview window. The generation method can be either by truss joints or by spacings. We choose the first option now. The properties of the sag rods can be adjusted as well. Here we have a clash now, but don't worry, we will deal with it later in ProtaSteel. Now, let's continue to insert the rest of the purlins. There is an important problem here. There is no member to support the last element on the edge. We can solve this issue by welding a steel frame member like the one already inserted above. Let's filter out the purlins from the view by using the vertical menu. Then, we insert a frame member as a reference. The last step is inserting a new frame member at the end of the existing one. We can remove the reference frame and show all the members again. We are moving on with the claddings now. For inserting each cladding element, you should select the purlin or girts over which it will be inserted. Like the other member types, the properties of claddings can be managed easily. You can watch the recommended video to discover that process in detail. The modeling part is over now. We can assign the loads over the roof. Let's go to the Loading tab and adjust the load cases and combinations. Open Automatic Loading Editor to generate the load combinations. We should check the box for creating different load combinations for steel member design. Then, we simply select the load cases to be considered for our model. For the seismic loading, equivalent static load or modal response spectrum can be selected. We will select the modal response spectrum now. Then, for the wind loading, we will include the separate negative load cases. After clicking OK, the load combinations are automatically generated. Before assigning the loads, make sure that the proper story is selected. Then, you can assign the loads through the load editor. On this window, loads can be assigned to each member on the fourth story. By using the vertical menu, you can filter the view for specific elements to work more comfortably. Since we will work with the loads acting on claddings, we are filtering out the rest of the members now. For the claddings, we select the full uniform area load option. After selecting the load case and entering the necessary properties, we click on Update and select on which members the load will act. As you can see, we assigned the load to all the cladding members at once. We follow the same steps to assign other load cases like roof live load, snow load, and wind load. Let's assign a point load now. The point load will be assigned to one of the steel columns, so we filtered out the cladding. We are selecting the load case, point load command, and the member now to insert the load. So far, we have covered the topics like modeling steel members and load cases. Now, we can move on with the building analysis. Open the building analysis window from the Analysis tab of the ribbon menu. By using the building analysis command, we will obtain the analysis results for the whole structure easily. Here, we can make the necessary adjustments for the analysis. First of all, it is important to have the slabs connected to the steel columns meshed with finite elements method. For this purpose, we go to the Model Options tab and enter Slab Model, then check the box to include slabs in Building Model. Also, check if the proper slab is selected to be meshed in this drop-down menu. Finally, we can start the building analysis now. At this point, we expect ProtaStructure to give us a warning. This warning informs us about the connection of the steel column at the fourth story to the slab. Since we are already aware of this condition, we simply click OK and continue the analysis. After the building analysis is completed, we can easily have all the concrete and steel members designed by using the Design All command under the Design tab. It is also possible to design each member groups separately. In order to design all the steel columns in our model, we select the proper option, and ProtaStructure provides a comprehensive table showing the design status of each steel column. However, the colors have meaning as well. The fact that the design status values are in orange now means that the displayed status is based on the results of the previous analysis. When you check the design of all the sections again, the color will be green, meaning that the results are updated. Then, ProtaStructure provides you a detailed design report automatically when you click on the Design Report option. Let's have the design checks for steel truss and frame members as well. When you double-click on a member, you open the design table of that member individually. Here you can see the design steps and details of the design checks. Plus, you can adjust the specific parameters for buckling and deflection manually. You can also view the load diagrams of the member. In addition to managing each steel member individually, you can also adjust the design parameters for multiple members at once by using the Edit Steel Design Parameters command from the right-click menu. You can visualize the design status results and check your model at a single glance. Through the Visual Interrogation menu, choose the Design Status option. You can easily see the design status of members on a color-coded model. You can also visualize the steel design utilization ratios through the same menu. Let's go through the analytical model. We filter out the first and the second floors to clearly see the analysis results for the steel roof. Recall that we placed a point load onto this column. We can check its impact on the slab by activating the contours. For this purpose, we will choose the live loads for load case and the displacement in the Z direction for the effect. Now, we can clearly see how the point load is transferred to the slab. After checking the effects of the loads on our steel roof structure, we can move on with the connection design on ProtaSteel. The steel structure that we modeled and analyzed on ProtaStructure and the loading information are automatically transferred to the ProtaSteel. During this transfer, concrete members are also transferred. However, their detailing process cannot be done in ProtaSteel. For that purpose, ProtaDetails should be utilized. Before starting the connection design process, we will open the filter options and hide the purlins and sag rods. For this purpose, we double-click on the work page and open the view properties. Now, we can work with the structural elements without dealing with a crowded view. Let's design the connections between this truss member and the columns. First, we will insert a base plate by using the macro gallery. We simply open the base plate connections, select a proper macro, click on the two members that we want to connect, and right-click. The properties window of this macro can be opened by hitting M and Enter. On this window, you can easily modify the parameters of this connection, including the section type. After making the proper adjustments, you should click on Apply and OK buttons to save the modifications. After inserting the base plate, we can now design the connection between the column and the upper chord and the diagonal of the truss member. We select a bracing connection for this purpose. Again, we select the connection macro and the members to be connected. We can insert another bracing connection following the same steps. It is possible to use the same macro for the connections of these beams with the column as well. As you can see here, the column should be elongated for constructive reasons. To make this simple change, double-click on the column and enter the necessary offset value. Apply. OK, and it is done. Now, we will connect these members with the same macro. Through the Properties window, we can modify the macro and have a welded connection instead of a bolted one. Click on the Switch to Weld Settings button. Then, check the welded option here. As you can see, the first member we selected is welded now. We will apply the same change on the second member. This is one way to have a welded connection. Of course, there is a second method as well. Instead of following those steps, you can simply select the welded pipe connection macro from the truss connections. Let's have these members connected with the welded pipe connection macro. Here on the edge, we have a short column. We want to cut the upper end of it to have a nice and clean connection. Hence, we will create a section cut. For this purpose, we select the View by 2 points options from the Views tab. It can be clearly seen that the column clashed into the upper chord of the truss member. To make the cut, we select the 2D fitting option from the detailing menu of the gallery. Then, we select the member to be cut and specify 3 points on the plane of cut. As soon as we click on the third point, the member is cut. We can show and hide the fitting object through the visibility options. Now, we can switch to the 3D view. After executing the fitting, we can weld the column to the upper chord of the truss member. We select the Weld option under the Steel tab and click on the members. The welding is completed. We can adjust the properties of this welded connection through the Properties window. We will insert a base plate connection for this column, and we need to execute another cut for the lower chord of the truss. For utilizing the 2D fitting command, we should select the members and the points along the cut plane. To see the members clearly, we filter out all the members except for the column and the lower chord. Then, we select the command, click on the lower chord as the member to be cut, and select 3 points on the cut plane. The lower chord has been cut. Again, we will weld these members utilizing the Weld option as we did earlier. This time, we will change the weld type as all around from the Properties window. Now, we can make all the members visible again. As a last work for this truss, we can also close the opening at the free end of the upper chord by inserting an end plate from the macro gallery. After selecting the macro, we click on the member and a random point at the free end. We can check if we created the assembly successfully by using the Select Assembly command from the right-click menu. When we select the Show Only Selected option, we can clearly see the assembly. Before finishing the video, let's check the connections between the truss members and the purlins. First, we need to clear our filtering choices to view the purlins. We can design these connections by utilizing the options for purlin and girt connections on the macro gallery. After selecting the proper macro, we click on the upper chord and the purlins to insert the connections. For the uppermost connection, there might be a clash, so you can move the purlins there on ProtaStructure if you want. By repeating the same steps for the rest of the connections or using the IntelliConnect tool, the design of this steel roof can be easily completed. For the details of modeling steel members, load editor and any other topic that you want to learn more, you can simply explore our channel. Thanks for watching. Don't forget to subscribe to discover more in the upcoming videos.